classification. On the other hand, when you have more than two categories, that example is called multi-class classification. Let's say you are working as a data scientist in a life insurance company, and your boss gives you a task of predicting how likely a potential customer is to buy your insurance product. And what you are seeing here is the available data, and based on the age, the information you have is whether customer bought the insurance or not. Now here you can see some patterns, such as young people don't buy the insurance too much. You can see like there are persons with 22, 25, these kind of ages, where 0 means they didn't buy the insurance. Whereas as the person's age increases, he's more likely to buy the insurance. So you know the relationship, and you want to build a machine learning model that can do a prediction based on the age of a potential customer. So as a data scientist, now this is the job you have been given. Now the first thing you would do when you have this data is you will plot a scatter plot which looks like this. When you have worked on linear regression problems already, the first temptation you have in your mind is you start using linear regression. So when you draw a linear equation line using the linear regression, it will look something like this. Now, how did we come up with this line? For that, you can follow my previous linear regression tutorials. If you think about it, what I can do here is I can predict the value using linear equation line and say that if my predicted value is more than 0.5, so here this is 0.5. If it is more than 0.5, then I will say, okay, customer is likely to buy the insurance. If it is less than that, then he is not going to buy the insurance. So anything on the right hand side is yes, anything on the left hand side is no. Now of course we have these outliers, but we don't care about them too much, because for 90% of the cases our linear regression will work okay. Now imagine you have a data point which is far on the right hand side here. So say a customer whose age is more than 80 years, let's say he bought your insurance, okay? Then your scatter plot will look like this, and your linear equation might look like this. In this case, what will happen is when I draw a separation between the two sections using 0.5 value, here the problem arises with these data points. Actually, the answer was yes here, but my equation predicted them to be no. So you can see that this is pretty bad when you use linear regression for data class like this. Now here is the most interesting part. Imagine you can draw a line like this. This is much better fit compared to the previous linear equation that we had, okay? And here, when you draw a separation between using 0.5 value, you can clearly say that this model works much better than the previous one. The question arises, what is this line exactly, and how do you come up with this, right? If you have learned statistics, you might have heard about sigmoid or logit function, and that's what this is. Okay, now the moment you hear this term sigmoid, you might pause this video and start googling about sigmoid, and it is fine. You can read all the articles about sigmoid or logit function to get your understanding correct on mathematics behind it. But if you don't want to do it, I will give you a basic idea. The sigmoid function's equation is 1 divided by 1 plus e raised to minus z, where e is some mathematical constant. It's called Euler's numbers. The value is this. Now think about this equation for a moment. What we are doing here is we are dividing by 1 by a number which is slightly greater than 1. And when you have this situation, the outcome will be less than 1, correct? So all you are doing with this sigmoid function is coming up with a range which is between 0 to 1. So if you feed set of numbers to this sigmoid functions, all it will do is convert them to 0 to 1 range, and the equation that you will get looks like S shape, right? So if you plot a 2D chart, it will look like S-shaped function that we saw in the previous slide. Essentially, what we are doing with logistic regression is we have a line like this, which is linear equation, and you know the equation for our linear line, which is mx plus b. All you're doing is you are feeding this line into a sigmoid function, mx plus b. So I applied sigmoid function on top of my linear equation, and that's how I got my S-shaped line here. All right, now all of this math is just for your understanding. As a next step, we are going to write logistic regression using sklearn library, and these details are abstracted for you, so don't worry about it. You don't have to implement all of this mathematics. You will just make one simple call and it will work magically for you. All right, so let's get straight into writing the code. Here is the CSV file containing the insurance data. You can see there are two columns, age and whether that person bought the insurance or not. And we are going to import this into our pandas data frame. So I have loaded my Jupyter notebook by running Jupyter notebook command on my command line.